This is video for Math 95 for sample test number 1. So this will be very much like the test that we're going to take. You'll have the same number of problems, the same types of problems, but different problems, okay? So this is just to kind of let you know what to expect when it comes time for the test. So let's get started. Let's see. So the first couple problems here are about inequalities. So the first one we've got is 1 plus 7 times 3 minus 5x less than 15. Okay, so the key here in this problem is we want to distribute the 7. Don't get sucked in and try to add 1 to 7 because the 7 can't be added to anything because it has to get multiplied by what's in the parentheses. So the 1 is just going to stay there, and then we'll have 21 minus 35x less than 15. All right, so that's now we can add the 1 to the 21 because this is not getting multiplied by anything. So we get 22 minus 35x less than 15. And let's see, we can move the 22 over here. Don't lose that minus sign. Negative 35x less than negative 7. And then if we divide on both sides by negative 35, that'll flip this around, and that'll be x greater than 1/5, or if you prefer decimals, 0.2. And then we want to put this on the number line. You don't have to get too involved in exactly where the 1/5 is. That's good enough, okay? The other thing you can do here, where you've got 22 minus 35x less than 15, subtract the 15 on both sides, and then move the 35x over here. So now you've got 35x greater than 7, and this just avoids having to flip that symbol around. You still get x greater than 1/5, still the same answer. But in this one, remember, we had to flip that around because I divided by a negative. Here, if you move it to the other side, then we don't have to flip it around. Okay, that's problem 1. Problem 2 is a compound inequality. So 12 greater than or equal to negative 2x minus 3 greater than 1. So in this one, remember, there's 3 places where we have to keep everything in balance. So if I'm going to add 3 to cancel this out, I'm going to have to add 3 here and add 3 over there. And so that'll be negative 2x greater than 4 less than or equal to 15. And then we're going to divide through by negative 2. And remember, we have to do that in 3 places. Let's see. And because we're dividing by a negative, that's going to flip those symbols around. So that'll leave us with x in the middle. This will be negative 2, and that'll be negative 7.5. So x less than negative 2, but greater than or equal to negative 7.5 will look like that. Okay. And then problem 3, we have an or statement. Let's see here. X plus 7 greater than 2x plus 1, or negative 2 times x plus 6 greater than 8. All right, well, let's get the x by itself here. Collect our x's on one side, so 3x plus 7 greater than 1. Subtract the 7. And then divide through by 3. So x greater than negative 2, or let's see, negative 2x minus 12 greater than 8. Add the 12 over. And then divide on both sides by negative 2. That's going to flip this around. And so we'll get x less than negative 10. So, x greater than negative 2, but less than negative 10. So there's greater than negative 2. And then over here, less than negative 10. It's an or statement, right? It goes off in either direction. You can either be over here or it can be over there. Problem 4 is an absolute value problem. And the key to these absolute value problems is to split them in two pieces. Here we've got absolute value 4x minus 5 equal to 15. And so we split it into two pieces. 4x minus 5 could be 15. 4x minus 5 could be negative 15. Okay, so now we have to solve these two equations. Add the 5 and divide by 4. So x could be 5. And over here, add the 5 and then divide by 4. So x could be negative 2.5. And there we go. X could be 5 or x could be negative 2.5. Problem 5 is an absolute value inequality. So let's see here. 2 times absolute value 3 minus 2x minus 6 greater than or equal to 18. So the first thing we want to do here is to get that absolute value, get this absolute value by itself. So we're going to add 6 to both sides. 2 times absolute value 3 minus 2x greater than or equal to 24. And then divide on both sides by 2. So absolute value 3 minus 2x greater than or equal to 12. Now we've got it by itself. And so now we want to split this into two pieces. 3 minus 2x greater than or equal to 12. 3 minus 2x less than or equal to negative 12, right? When we make this 12 negative, that flips that symbol around. And that didn't happen here because the equal sign is the same on both sides. Okay, let's see. Subtract 3, don't lose that negative sign, minus 2x greater than or equal to 9. And so then x less than or equal to negative 4.5. And then do the same thing over here. Let's see here, negative 15. And then divide on both sides by negative 2. X greater than or equal to 7.5. So there's our 7.5. So there's x greater than or equal to 7.5, and then the negative 4.5, x less than or equal to negative 4.5. And that's what it looks like on the number line. Okay. Now we get into the factoring problems. And this first one, problem 6, is just a straightforward trinomial factoring problem. So let's take a look at that. So, x squared plus 11x minus 42. So we need factors of 42 that have a difference of 11. Well, if you know 6 times 7 is 42, that one's not going to work because the difference of 6 and 7 is 1. And this one's not going to work either because this gives us a difference of 41. So let's see, 2 times 21, that has a difference of 19, also no good. Let's see, does 3 go into 42? Yeah. 3 times 14, those have a difference of 11. 14 minus 3 is 11. That's what we want. So, we'll put the 14 and the 3 in there. We need the 14 positive to give us positive 11, and the 3 negative. Okay. Problem 7. Notice problem 7, the format. You've got 4 terms. This is a factoring by grouping problem. And so the key here is to split this into 2 pieces and factor those 2 pieces separately to begin with. So here our common factor is x squared and then x plus 5. You see the minus sign? That tells you to factor out a minus 3. And that'll leave us with x plus 5. Now factor out the x plus 5, and that leaves us with x squared minus 3. So that's the factoring by grouping problem. Let's see. Problem 8. 3x squared plus 16x plus 20. I don't see any common factors. Now the 16 and the 20 share a common factor, but the 3 doesn't. So really I think what we need to do is to split this up. The 3 is prime, and that's helpful. That means this will be 3x and 1x. And then we want to fit the factors of the 20 here and here so that we can add these up to be 16. So let's see. 1 times 20, 2 times 10, 4 times 5. Those are our only choices. So let's try 4 and 5. That'll be 15 and 4 is 19. Nope. 4 and 5. There's 12 and 5 is 17. Also no good. Okay. 2 and 10. 6 plus 10 makes 16. Good. That's what we want. It's positive 16, so those should be plus and plus. Problem 9. 6x to the third minus 27x squared minus 15x. So right away, I think we can see that all of these terms have an x in it. Now, the only thing that all of them have is x to the first, so that's as much as we can factor out. Then let's see, these are not divisible by 6, but all of these numbers are divisible by 3, so we can factor that out. That'll leave us with 2x squared minus 9x minus 5. And now we want to factor this. This is a straightforward trinomial. Let's see, if I put the 5 here and the 1 there, there's 10 minus 1 will give us the 9, and we need the 10 negative and the 1 positive. So there's problem 9. Okay. Got a couple more problems here. Problem 10. (7x squared equals 2x). Now a lot of people want to divide on both sides by x, and I don't know if high school teachers are teaching that or not, because I see so many people do it and they seem very surprised when I tell them that that's not correct. What we need to do here is push everything to one side. So let's move the 2x to the other side. Set this equal to 0. 7x squared minus 2x. Now, factor out the x. X times 7x minus 2 equals 0. And split this into 2 pieces, right? This x could be 0, or 7x minus 2 could be 0, which means 7x equals 2. And x is 2 over 7. Now if you write this as a decimal, what is it going to be here? 2.857, something along those lines. And that's fine too. But the key here is that you get two answers. X could be 0 or X could be 2/7. Now if you take this problem and you divide on both sides by X, you only get one answer. X equals 2/7. You lose the answer of X equals 0, which in many cases is an important answer. You lose that answer because when you divide by X, you can't divide by 0, and therefore you're eliminating the possibility that X could be 0 if you're dividing by X. So again, please don't do this. It's not correct. All right, problem 11. Nine x squared plus 20x minus 21 equals 0. Okay, now this one's a little trickier than some of the other ones because the 9 is not prime and the 21 is not prime. We've got a fair number of things we have to try here. And I always recommend starting out with the smallest factor pairs to begin with. So let's try the 3x and 3x. And let's try to match this up with the 3 and the 7. Let's see what we get here. 3 and 7. 9 and 21 is 30. Let's see. Oh, I'm looking for a difference. I'm looking for a difference of 20. So 21 minus 9 is going to be 12, not 20. Okay. So that's no good. Swapping the 3 and the 7 doesn't make any difference. It's still going to give us a difference of 9. Let's see here. What if we did the 1 and the 21? That's not going to work because this is going to be 63 and 3, which has a difference of 60. Okay. So I think the problem was that it's not 3 times 3. Now let's try 1x and 9x. And let's try the 3 and the 7. Let's see. 63 minus 3. Again, we're getting a difference of 60 in that one. Here, 27 minus 7. That's the one we want. 27 minus 7 has a difference of 20. Okay, this is a positive 20, so we need the 27 positive, and we need the 7 negative. Okay, now that we've done that, now we can solve the equation. This is set equal to 0, right? So then we split it into two pieces. Say x plus 3 could be 0, or 9x minus 7 could be 0. So x could be negative 3, or x could be 7 over 9, which is 0.7 repeating, if you like decimals. All right, so there's problem 11. That one was probably the trickiest factoring that we've seen on the sample test so far. Let's see here. Problem 12. So notice that this one started out in what's called standard form. You had ax squared plus bx plus c set equal to 0. In problem 12, we have to take this equation and put it into standard form. So let's go ahead and do that. Okay, so first off over here, x plus 5 squared means x plus 5 times x plus 5. That's going to be x squared plus 10x plus 25. Over here, let's see, 6x squared, 2x minus 9x, so that'll be negative 7x minus 3 plus 4x. Okay, let's see. Let's combine our like terms over here. I've got a positive 4x and a minus 7x, so that's going to be minus 3x. Let's see here. So now I'm going to move all of this over to the other side. minus x squared minus 10x minus 25. Okay, so those all cancel, leave us with 0. This will be 5x squared minus 13x minus 28. Okay, so now we've got this in standard form, and we want to factor it. It's nice that the 5 is prime, because we don't have a choice for the factors. It has to be 5 times 1. So 5x and 1x. For the 28, we could have 1 times 28, 2 times 14, or 4 times 7. I'll try the 4 and the 7 first. And let's see, I'll try the 7 here and the 4 here. That'll give me 20 minus 7 gives me the 13. Excellent, okay. So 20 minus 7 gives me 13. This is a negative 13, so the 20 has to be negative, and the 7 has to be positive. Okay, now we're all set to go here, and we can solve for x. So x minus 4 could be 0, so x equals 4. Over here, 5x plus 7 could be 0. 5x is negative 7. X is negative 7 over 5. Or if you like decimals, negative 1.4. They're both correct. So that's the test, okay? Like I said, your test will be very similar to this. They'll have the same types of problems, the same number of problems, really the same level of difficulty on the problems, but slightly different problems, okay? As always, you'll have an opportunity in class to ask any questions you have about this. And so if you have any questions, please let me know. Thank you.